And we are live, looking at a custom view of the sun, 193 angstroms. Coronal holes facing the Earth right now. And as sunspot 2736 sets and goes completely out of view, we see the sun returning to an extremely low state of activity. By the way, SDO has fixed their site. Those of you who are looking for custom images of the sun, head over there. They've now made it a little better than it was. And for that, we thank you. Here are magnetic lines at 304 angstroms. And whoops, those are from the 22nd. No data on that. All right, let's look at the last 48 hours and 304 angstroms. Quite a lot of activity associated with that setting sunspot. Give that a moment to load. Not being particularly cooperative. All right, so there's that view. Regular viewers, we almost made a produced video this morning. We now have screen capture software on the PC to bypass the non-functional software associated with certain social media companies, which will remain unnamed. Certain companies that we've been very critical on, who are very, very bad at writing software, but very, very good at spying on you, yes. Now, we're not going to make this report too long today, so let's just move on to the real-time solar wind data. So we see no phi angle really riding the 180-degree mark there. Oh, actually we do. We see a significant, let me get my draw on screen tool here. Hello, Eden sent. So we do see a series of near 180-degree. All right. Thanks for interrupting me while I'm talking, you stupid software. I'm ready to fight all software companies by creating a software company. Here we see the phi angle. Right. All right, I'm about to snap. Here we see the phi angle riding around the 180-degree mark for a long period of time. Although it looks like it just sputtered off of there, so it looks like the coronal holes just disconnected, although we would not be surprised to see reconnections throughout the day today. Solar wind density right around 10 protons per cubic centimeter, and we see a recent uptick in the solar wind speed, but still very low, staying below 350 kilometers per second over the last 24 hours. We have seen a decrease in the 10.7 centimeter radial flux, which is why we're here at spaceweather.com, as they list this statistic. We were all the way up to 80 or 79 there. And for those non-regular viewers, 10.7 centimeter radial flux is a proxy for sunspot number. It follows sunspot number almost perfectly, and this is as a result, a proxy of solar cycles. So you see the predicted values. We are much higher than those, and for that, we thank you. And let's look at spaceweathernews.com. which, by the way, if you're viewing in Brave browser, views better as a desktop site. We see the X-ray flux is dropping into a more normal region here, as we were at a constant B flare range. And we should be dropping down with the setting of that sunspot. We see some pretty serious magnetometer perturbations there. And we'll look at the Gong 2 in a moment. Also, the KP index was all the way up to 3, and now it's back down to 1. There's your electron flux, indicating that that increase in the solar wind speed and the KP index was probably from a coronal hole wind stream. Although we did see some ejecta, and we'll be searching for it in a moment. We don't see any charging hazards, and the F2 layer is actually pretty charged on the sun portion and normally discharged on the nighttime side, that is. There's your auroras. Nothing too exciting to write home about there. Next, we've got the Gong 2 data. Bear in mind this is 2 hours and 20 minutes old, which means it should be updating soon. There is the magnetic environment. And we're going to have to blame the GOES magnetometer perturbations on plasma, because it's not because of a direct connection with the sun. Let me just explain by showing you the last frame here. We tend to see a weak magnetometer when the Earth's lines go to these bunched up areas, and those are dense portions of plasma in the outer portion of the corona. Good morning, College-An. And when we see these more straight lines that go all the way to the corona, we see higher GOES magnetometer readings. We just went through a bunch of perturbations, which were all in this area here. And we should see a significant spike as the Earth is on its way into going to this region. And that's going to be a more direct magnetic connection there. And that's going to be an earthquake increased risk because of coronal hole connections. This plasma here in these areas where you see this plasma bunched up like this, that tends to act as a magnetohydrodynamic insulator. We hope that makes sense. And let's move on to the geospace magnetosphere movies as we look at these every day to at least compile some data on it. It looks like we got pretty high density here, actually. And that is reflected in the solar wind as the protons are about around 10 per cubic centimeter. First, we'll play the velocity. Give that a moment to load. And that gives me a moment to thank viewers and subscribers and urge you to press that like button, leave us a comment, and subscribe to the channel if you haven't already done so, and share on your social media, as this channel is what you would call shadow banned. So there's the velocity, nothing too extraordinary going on there. By the way, don't worry, folks, the musical format's going to come back. Here's the density. We see very high density, also reflected in the solar wind. Just remember, this particular one, high density is the blue portion and low density is the white portion. And here's the pressure. Fairly low pressure associated with a fairly low velocity. It's a little bit of F equals ma for you there. And let's look at the geospace ground perturbations, as I haven't looked at these for a while. First, we'll look at the poles, and then we'll look at the full globe. As this is where the Birkeland current sheets arrive. Head to the source, right? I don't know what that means, Dothvelo. So here are your ground geospace magnetic perturbations. And as you may expect with such a slow solar wind, you don't see many perturbations. Here's the view from the globe. Not a lot going on there. Let's look at quakes.globalincidentmap.com, which is offline for some reason. There we go. Click to the satellite view to make it more visually pleasing. And the earthquake drought continues. We see a 4.3 at a deep depth there in Argentina, right in our daily watch zone. 4.4 in Indonesia, right in the daily watch zone. 4.2 in Russia, also at depth, 139 kilometers. See where that's located. On the Kamchatka Peninsula. No surprise there, as that is a constant area of activity. We're seeing an overall drought here. Here's one north of Severnaya Zemlya? What is that? Never heard of that. Oh, very far north. Okay. That one's so far north that it's at the North Pole. Wow. That is interesting. That's the farthest north quake I've ever seen, as it's about as far north as you could get. And also a 4.5 in Indonesia. So the magnitude 6 and 7 earthquake drought continues. If you're in these areas, please have an earthquake plan. I feel like I'm beating a dead horse when I say this, but 6 and 7 magnitude earthquake droughts end in 6 and 7 magnitude earthquakes. So those areas, in the event of a disaster, try to be an asset instead of a liability. All right, let's move on to some other things here, like volcanoes, as we see at least one new entry on the list. And we have poor network status for some reason. Please let us know with a comment if everything looks okay from your end, as I can't see very much. Today's volcanoes. We see Vesuvius back to erupting. A swarm of quakes at Vesuvius. And what they're saying is that it's really heavily monitored. It doesn't look like anything too extreme is going on. Shivaluch, volcanic ash not identifiable. Bromo, producing a 12,000-foot ash plume there. Ducono, 7,000-foot ash plume there. Fuego, a 15,000-foot ash plume. Revenador, don't try to broad jump it at 16,000 foot. Sabancaya, producing a 22,000 foot ash plume. Keep your drones away from the caldera because they'll get destroyed. Let's look at space weather beacon here at the streAm satellite. And it was loaded, but now it's not. All right, we're going to get a custom view here. We're going to back this thing up. I'm going to go 1 frame per second at 100 frames. And this thing's playing really slowly for some reason. Just blow it up big enough so you can see the date stamps. I don't know why it's playing so slowly. It's super annoying though. Let's make it 5 frames per second, see if that helps things. So this is going all the way back to the 22nd here. And I'll keep that small enough so we can see the date stamps. I thought I saw some more coronal mass ejections, but perhaps not. And let's just go to the most recent here. Oh, we're starting from the 23rd. All right, I don't know how that happened. It must have defaulted to that. Here's a more up-to-date view as I stumble around this software. 24th, there's a 25th. And we do see more ejecta coming off the sun late yesterday. So there's another coronal mass ejection, folks. You can see it starting there. And we're going to look at the LASCO C2 and C3 to see how Earth-facing that might be. We're kind of doing this in the backwards manner here, but you have to look at it from both views. Before we look at the LASCO, I just want to look at the Space Weather Enthusiast dashboard for a second to explain to new viewers what we're looking at. streAm Space Weather Beacon is part of the streAm satellite. So, just to illustrate this, here's the sun, here's the Earth, here's streAm, and here's streAm. The reason that we look at streAm is because streAm doesn't work anymore, but it experienced some hardware anomalies in 2014. It doesn't work. So when we're looking at that streAm Core 2 Space Weather Beacon, you're looking at this orientation at the sun, and then the interplanetary magnetic field is going to show on your right side like that. And that's why we're looking at ejecta from streAm Core 2 Space Weather Beacon. All right, I hope that helps. Now we're going to go to we're going to head to SolarHam real quick because they put the LASCO C2 and C3 right on homepage. So go over and check out solarham.net. And I clicked on the wrong thing. So you just click on the image itself. And then here's the 48-hour GIF animation. And what we're looking for are halos where we see the plasma on both sides of the disk. That means that it's coming toward you. I can't shrink that down any smaller. It looks like some ejecta will hit the Earth from that. Let's let that play through one more time. I know it happened late last night. There's some ejecta from the 23rd. That is a tough one to call. It looked like an Earth-facing coronal mass ejection to me. Let's move on and look at the C3. Maybe it'll give us a little more insight. Here's the 24th. That looked like it should miss the Earth to the west. And is this showing us old data? 23rd. There's the 24th. There's the 25th. So it looks like this looks like it needs updating too, folks. I don't know. Whatever. There's some ejecta. Some of it appears to be Earth-facing. Let's move on to more things, such as this Zero Hedge article. Navy ready to burn boats with new laser weapon. For real. Anyway, check out that article on Zero Hedge if you're interested in directed energy weapons, which, as I know, some of our viewers are. Scientists witnessed storm formation, on Neptune for the first time. There's some images. And that dark spot you see there appears to be similar to Jupiter's red spot. These images are from 2018 in September and November using Hubble's wide field. So another interesting article talking about storms on Neptune. Here's another one from extremetech.com. Apparently they were saying the same thing that we were. So when I say we were wrong, I'm talking about this channel, NOAA, NASA, and every other space weather forecaster I know of. They were expecting a solar storm. They predicted it even earlier than we did. But anyway, just wanted to cite that because there are still articles on main pages of websites talking about the coronal mass ejection that never arrived on Saturday and instead showed up on Sunday night. Here's one from phys.org. What ionized the universe? The ionization of the universe doesn't seem to add up with standard cosmological models, as when we measure the radiation coming out of a galaxy, it does not account for the amount of ionization in the universe. So the cosmic microwave background is not a real thing, since it can't be measured and replicated. And this is an important aspect of cosmology here, because it's not clear how the universe got so ionized. So anyway, another interesting article about cosmology. And here's a website about cycling. If you're into it, check out theveloshop.net. Pretty much every kind of bike you could imagine. Owned by a world-class cyclist, Becky Quinn. And she is a specialist in bike fit as well as, well, she runs spin classes and she's a legit expert. So let's look at some of the athletes, such as Kim Geist and Kim Zubris, who are currently wearing world champion jerseys in the Madison, a track racing event. And yes, they are part of the U.S. national team as well, but when they race locally and regionally, they wear the veloshop.net gear. Let's go back to the sun, because this live stream is just about complete. We're going to try to produce another video today, one that's highly produced. And we do have the right software. We're just working on making sure the production is right, because we don't want to release any videos with this important space weather stuff and mess it up. So that's what's going on. And there's a lot of stuff to do today, so it's about time to get out of here. I would note the crazy magnetic looping going on here, especially north of this sunspot. There's like a magnetic fountain pyramid being built up there. And this view, by the way, is 171 angstroms, which is ionized iron. Let me go through the chat. Thank you for commenting, everybody. Thank you for joining us. Eden Sent, Kalojan, Das Velo, and Harry Vire. If the sun is condensed matter and we see CMEs, and it is electrically fed pulsing over time, rather like the quartz in your wristwatch, then the likelihood of a mini micronova makes sense. That's a good question. Are you suggesting that the liquid metallic hydrogen model refutes the recurring nova idea? I don't think it does. Now, I heard Ben Davidson talking about this a few days ago, and what he was saying was, in order for a nova event to happen, you don't need sunspots, and that's what I was saying also a couple weeks ago, because you could have that come out of a coronal hole. What if we have a coronal hole that connects the south and north poles? No idea what would happen. But I would assume catastrophe, because the magnetic connection would be extreme. So I don't think the condensed matter model of the sun is any kind of a refutation of nova model. Now, in the liquid metallic hydrogen sun model, coronal holes are caused by outgassing of intercalate regions. So the condensed matter on the surface, like you want to say the photosphere, for instance, which is the part that you see that appears dark inside of a sunspot, that's going to be a flat lattice similar to graphite. And in between each flat layer of that, you're going to have other gases that are non-hydrogen gases. And when you have voltage changes on the outside of the sun, that's going to vaporize that gas. And when that happens, it outgasses, because it's only being held in by a liquid. So that's Robitaille's theory of how the coronal holes work, and how come coronal holes spew out solar wind the way they do. I don't think that model refutes the nova model. And, you really got to include the nova model into your theories because of what the geological records show. The geologic record clearly shows cyclic patterns, black mats, the KP boundary, all that sort of stuff. Good morning, Tigus. We're hoping you guys get a summer, and we're hoping we don't see the Thames freeze, because England is the canary in the coal mine for global cooling, which, by the way, is deadly, unlike global warming, which, by the way, would increase crop yields around the world. You set your cranks up like the Velo logo, huh? I guess that gives you a good abdominal workout, doesn't it? All right, folks, we got to get out of here. Thanks for tuning in. And we're planning on putting out another video or two today. So remember, when you're staring at the sun on 171 angstroms, don't drink. And if you drink, don't stare at the sun on 171 angstroms, or do stare, but just don't drive. And since it'll never be now again, may the solar wind be at your back and the atherosclerosis absent from your arteries.